We're finishing up the last two examples of section 11.3b goal 4. Remember, I ask you not to watch this until you have completed 3A, B, and C. So if you have not yet done that, I need you to pause the screencast and work through 3A, B, and C now. All right, so quickly, the derivative of f of x equals -1, hopefully you said was 0. We know that y equals -1 is a horizontal line, and the slope of any horizontal line is 0. So the derivative of any constant will always be 0. In example B, the derivative is -5. And the slope of the tangent line equation, or the slope of the tangent line formula, was not necessary because this is a linear function whose slope is -5. Now C was a little bit tougher. So your derivative is -3 over x to the 4th. The first thing I want you to do if your answer is incorrect on C is to look back through and see if you can't find your mistake. If you still can't correct this one on your own, then I am going to work this out and you can watch me work it out and talk you through it. However, again, it's very important that you try to find your mistake and correct this on your own before you watch me work example C. So I've already completed the formula for the slope of the tangent, and now I'm going to go through the process of simplifying it. So if we were to plug in 0 right now, we would end up with 1 divided by x to the 3rd minus 1 divided by x to the 3rd. 1 divided by x to the 3rd minus 1 divided by x to the 3rd, which would give us 0 in the numerator. And if we plugged in 0 in the place of h in the denominator, we would have 0 over 0. So we know that we have a common factor embedded in here somewhere in this complex fraction, and we have discussed in class that in order to simplify, we've got to simplify the complex fraction, or in order to simplify that common factor, we've got to simplify the complex fraction. I'll start with my common denominator. Let me remind you again, please keep your common denominator in factored form. So I know that I would multiply this first fraction, the first numerator, by x to the 3rd, because its denominator is missing that common factor, minus, remember to follow the minus with parentheses, and I'll multiply the second numerator by x plus h to the 3rd. And then, of course, this is all divided by h. Okay, so I know what you're thinking. Do we have to raise x plus h to the 3rd power? My answer is yes. So if you did not do this on your own, I want you to stop and do this now. All right, so I'm going to go to the next page if you need to see this and raise x plus h to the 3rd power. So we know this is x plus h times itself All right, so I'm going to multiply the first two binomials together using FOIL. So that will give me x squared plus 2xh plus h squared. So now we will multiply by x plus h. Let me get rid of what looks like a negative. Okay. So I have to distribute x squared to x, so that gives me x cubed, and to h plus x squared times h. I'm finished with the x squared. Now I will distribute 2xh to x. That is 2x squared times h. Notice I'm vertically lining up my like terms, and then plus 2xh squared. I like to vertically line up like terms because it helps me to see them more easily. Finally, I'll distribute the h squared times x, which would give me x times h squared plus h cubed. So now I'll add all my like terms. And so now I have expanded x plus h to the third power. I'm going to take that back to the previous page and put it back into the problem. Okay, so where are we? So I have expanded x plus h to the third and placed it here, and then just copy down everything else as is. So now if I follow order of operations, it tells me to distribute this -1, so that makes this plus a negative, a negative, a negative, and a negative. And immediately I see that the x cubes will cancel, but no other terms will cancel. So at this point, if I plug in 0, for h, I'll get 0 plus 0 plus 0 all over. And again, I'll still have 0 divided by 0. So I have to still look for more opportunities to cancel a common factor. And so I notice that these three terms all have a GCF of -h. So at this time, I will factor out -h. And that leaves me with 3x squared plus 3xh plus h squared, all divided by x cubed times x plus h to the third. And how do I divide by this h? I multiply by its reciprocal, 1 over h. And finally, I can cancel these pair of h's. And as soon as they're canceled, now it's okay to evaluate my limit as h approaches 0. So I have negative 3x squared. When I plug 0 in for h, I know that will cancel to 0, and the same for h squared will cancel to 0. Divided by x cubed, x plus 0 is 0, and then x plus 0 is x, and then raised to the third power is x cubed. So I have negative 3x squared divided by x to the third times x to the third is x to the sixth. And then I see I can reduce this to -3 divided by x to the fourth, which is my derivative. Lastly, example 4. You've got a couple of problems on your homework that they tell you to use your graphing calculator to graph the function in the tangent line. So make sure that you find the equation of the tangent line, and then you will graph both the function and the tangent line on your calculator through the given point. And you'll use that to confirm that you do have the correct slope. If you need help with that, I'll be happy to go over it with you in class the next time we meet. Thanks so much.